Hi, we're just going to look at some vocabulary to practice with the statistics information that we learned about population samples, representative populations, and random samples. So let's look at that. So I'm actually this is from our statistics packet, page 4, and I'm going to look at some of the wording here. It says, students at your middle school are surveyed about their favorite beverage, their favorite drink on the cafeteria menu. So we're going to look at these 3 pieces of the survey and see what would we call that. 10 students sitting together at a table in the cafeteria, every student who attends your middle school, and 10 students whose names are chosen from a hat without looking and the hat contains a number of tickets equal to the number school's population and each labeled with a student's name. That's very detailed. Okay, so as I look here and I think about this, if I want to survey students who attend the middle school about their favorite beverage, then the population would be all the students who attend the middle school. So that means this middle thing here must be the population. Oops. Population, period. Okay, good. No period. Then I look at the other 2 things. Well, both of them say to 10 students. Well, 10 students is a piece, a sample of the whole population. But what makes something like number 10 different from the first 10, different from the other 10? Well, in this right here is just a sample. And that could be a bias sample. Because maybe I just pick my friends, or maybe they might all have something in common. They're all in the same grade, so that's a bias sample. Whereas this is a random sample because I'm choosing the names at random from a hat. So I'm going to call this a random sample. So that's what I'm going to put for those answers. Let's look at the next one. I went too far. There it is. Hold on. Okay, next situation. The mayor of your town wants to know if residents will vote to build a new library. So who is he concerned about? Well, he's concerned about whether the residents want a new library. So the residents would be the population. But you have to be careful because they're going to vote. So maybe someone's a resident, but they're not registered to vote. So they're not going to be able to sway it one way or another. So what he wants to know is if they will vote, that means all the voters are the population. Oops. Population. So 50 town residents who are voters, 50 residents whose children attend the public schools. Okay, well, both of those are samples, but which one of them is a representative sample? Well, since these are people who vote, and it can be from any walk of life, no matter what their age is, as long as they're in voting age, this one is the representative sample. We don't know how it's chosen, so I'm not going to say whether it's random or not. I'm just going to say it's representative. Representative sample. 50 residents whose children attend public schools. Well, that's a sample of the population, but we don't know if it's we don't know whether it's a good sample because we don't know if all of those people are registered to vote. But that would be a sample. Okay, let me scroll down again. So far, there we go. And let's look at this last one here on this page. Okay. A newspaper wants to identify a city's favorite museum. A newspaper wants to identify a city's favorite museum. Well, a city isn't really a thing that could have a favorite. Like a city doesn't have a mind. So when they say a city's favorite museum, they're really talking about the people who live in the city, because that's who we're calling the city. So to the people who live in the city, what's their favorite museum? So all the residents of the city would be the population. I'm going to abbreviate POP for population. Residents who are randomly selected from the city census. Visitors at the Science Museum on Friday night. Okay. Well, the visitors who are already at the Science Museum are probably a biased sample because they're already choosing to go to the Science Museum, so that's probably their favorite. So this is a sample, but this would be an example of a biased sample. Whereas residents who are randomly selected in the census, they're selected randomly, so this would be a random sample, which probably, because it's random, would also be a representative sample. So I would use either of those two answers here. I'm going to call it random because it says it's randomly selected. So those are a review of some situations and how to decide, what's the population, that's like everybody who's being involved, and then what's a sample and what's a representative sample would be one that everybody has a chance to be chosen and it represents the whole group. So let's look at a couple more examples together. So we're just going to do a couple from this page 5. This is actually taken from the textbook, pages 315 and 316. So if you don't have this packet, you could actually find number 5. It'll be somewhere on the page. This is just organized a little easier. So it says a journalism teacher wants to determine whether his students would prefer to attend a national writing convention or a tour of their local newspaper press. So the journalism teacher has a total of 120 students in 4 classes. What would be a representative sample in this situation? Okay, so this is a really open-ended answer. I could give you an answer, but you could have an answer too that would be just as good. So I'm just going to give you like an idea of what an answer would include. So what would be a representative sample? Well, we want to make sure that when this sample is chosen, that everyone has an equal chance of being chosen. We also want to make sure that it is people from each of the 4 classes get a chance to be chosen. So you wouldn't just say, well, I'm just going to pick one of those 4 classes and say whatever they think, because that would be biased. So I want to make sure that everyone has a chance to be chosen and I'm not being biased. So one way to do that would be to have a way to randomly, so we want to randomly select some of the 120 students. And a good number would maybe be like 20 of them. So maybe you want to randomly choose 20 students. You could have said 25. That would be fine too. It wouldn't be like 5. That would be too small of a number, but 20 would be good. So randomly choose 20 students. Now, how can we randomly choose something? Well, there's lots of ways. One of the easiest way, if you remember, when you were in elementary school and they wanted to pick somebody's name, they'd pull out the popsicle sticks. So, or you take a name out of a hat. So if you have all 120 names, or maybe you have like a random number generator or random name generator, where you can type in all 120 names and then you allow the computer to randomly select one of those names and select 20 of them. You can do that too. So there's lots of ways of randomly selecting, but you want to make sure the sample is not too small. So 20 is a good amount, and you want to make sure that everyone has an equally likely chance of being chosen. So something to that effect would be a good answer. You'll notice in statistics, it's not as exact. I also want to talk about number 10. So number 10 says, a national appliance store, they sell stoves and dishwashers and things like that. A national appliance store chain is reviewing the performances of 400 sales associates, their trainees. How can the store choose a representative sample of the trainees? They just want to kind of get an idea of how are things going, and they don't want to evaluate all 400. So what would be a way to get a representative sample? Well, in order for it to be a representative sample, it would have to be random. So you're going to randomly choose, and what would be a good number? We don't want it to be too small or too big. So let's say randomly choose I'm going to say probably like anywhere between 40 and 80 would be a good number. So somewhere between 40 and 80. So I'll say 50. I'm going to randomly choose 50 trainees. Now, how am I going to do it randomly? Well, there's lots of ways. We just talked about that. But one way could be if all 400 trainees had a number assigned to them, 1 from 400, and then you used a random number generator to randomly generate 50 of those numbers, and then those could be the 50 people in your survey, and that would work too. It's another way to do it. Assign them numbers and let a random number generator randomly select them. What you don't want to do is just like, scan the room and go, you. That's biased. So in order for it to be unbiased, it has to be random. And that means that you're not making the decision, you're letting something else make the decision, like a computer or pulling it out of a hat, that type of thing. Okay, so now I'm going to look. This is actually not from your textbook. This is from the extended practice. This is on page 6 in the packet. And it says, the manager of a cinema with multiple theaters, so a movie theater that has multiple theaters in it, like the one in Hanover, randomly surveyed customers about whether they would prefer to view a new movie in regular or 3D. The manager recorded the results of the survey. Now, out of the group of 500 customers came in. Every 10th customer was chosen. So it's like one walks through, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th person, stop. I have a question for you. 3D or not 3D? Good. Then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop. I have a question for you. 3D or not 3D? And then he documented it. So he did that. So if that's the case, if he's asking every 10th person, then how many people are in his sample? So if it's every 10th person, how many people are in the sample? Well, that's just going to be the 500 scales down to what number? Well, I'm taking a 10th of it. So what's one? So I want a 10th. I'm going to multiply this by a 10th. A 10th of 500 is 50. Some of you are like, I just divided by 10. Good, that works. So 50. So the total sample is 50. So that means, suppose that he surveyed every 10th customer. Let's fill in the table. I'm sorry. I thought that was what I was going to ask. Complete the table here. Complete the table to describe how many residents would prefer. Well, if 30 of them like regular, then the other ones out of the 50 must be 3D. So 50 minus 30 is 20. There you go. So 20. So now I know 20 like 3D and 30 like regular. Well, I can then imagine if that is representative, I can scale that up and think, well, that means that how many people out of 500 would like 3D? Well, that would be out of 500, I have to multiply that by 10 because my scale factor is 10. My scale factor here would be 10. So we're thinking like, if the survey is correct, then like 300 people would like regular and 200 would like 3D. What that tells me is it's almost half and half, but there's still more who just like the regular. And we don't know why they prefer the regular. We just know that they did. Suppose the manager surveyed every 10th customer who viewed a movie at the cinema on Sunday afternoon. Is this a representative sample? Okay, so now we're being more specific. If we just pick a day, like Sunday, is that a random sample or representative? Well, no, because we don't know what type of people visit on Sunday afternoon. Like, who is going to the movies on Sunday afternoon? Is that like the common time that everybody goes to the movies? Not really. So wouldn't you need to kind of get a broader picture? Like maybe the people who really like 3D, maybe they often come Friday nights. I don't know. I wouldn't really know for sure. So I want to do this for more than one night. So we're going to say, no, this would not be representative because it's only one night out of the week. and we don't know what people on a weekday might choose. So no. So it's only, I'm going to write no. I'm not going to type it in, but no, because it's really only one day of the week, and that's a bias. So we should probably do it more than once. And I want to look at one more where we're scaling. So let's look at number 3. Suppose a population of customers contains 100 adults and 25 children. If a representative sample from this population contained 12 adults, how many children should they sample? So this is tricky. They're saying, okay, so they took from this 100 adults, and they're like, we're going to only look at 12 of them. So they scaled it down. So what did they do to 100 to get it down to 12? Well, I have to think to myself, what would I multiply 100 by to get 12? So I'm going to divide it by the answer. I'm going to do 12 divided by 100, and I get 0.12. So I'm going to multiply. If I multiply 100 times 0.12, I get 12. If that's true, then let's go up here to 25. So then if I want to keep the same ratio, then I would have to multiply 25 by the same scale factor. So 25 times 12 hundredths equals 3. Equals 3. So that would be 3 children and 12 adults. So there you go. There's an example of how you can use scaling to answer a question. There's another one like that on the example problems. But from here, you could just check your answers in the answer key. Keep practicing. Thanks.